All right, so welcome back to I think the ninth or eighth or ninth meeting. I didn't give count anymore, but in today's meeting we'll be talking about a few things. In the previous meeting, we've done a lot of hands-on course. Like we've been able to change the colors of different objects. We've been able to when we use collision. So if you use on collision enter, it's like a type of method. We can like we can make some collision between each things, make interaction. Oops, my bad. So what happens is if uh if like an object hits another object, like our player hits another object, then we made the object's color change from something to blue, I believe, last time. And then we also learned a bit about get component, so like how to access the material itself from the components, right? So we use that method called get component, which is available in Unity when you use their API, in other words, like the libraries. So what we'll be doing today is, I think that let me just share my script machine if that's possible. Oh yeah, wait, I'm using OBS. Yeah, so if I go back here, there are not a lot of things. I think we're gonna start it off with lighting. So we're gonna learn about how there are many different type of lighting features, and we want to go a bit in depth today on how these different lighting stuff works in Unity, all the things that they made for us, and how it's super valuable to make your games super realistic, super professional, and really like triple A kind of great video game, right? But we need to make sure that although these tools are amazing, we're using it the right way. Because if you don't know how to use tools the right way, sure, the tool can be really good, but you also need to have potential in knowing how to apply these type of lighting effects in different places in Unity, right? And then we're going to learn about that. We're going to learn a bit about like the lighting concept itself. And what I want you to do today after we run this meeting is like start adding some lighting effects inside of your game to make it look a bit more of your style, the theme that you're trying to look for. Make the intention that you're trying to look for in your game and try to execute it using lighting, because lighting is a really important feature, at least especially in daily life. It's a thing that's how we can see everything around us. It's also in our eyes. We cannot really perceive things without seeing light itself, right? So lighting is really important, not just in real life, but in video games. It just makes your game a bit more vibrant, a bit more of your style that you want. And I know a lot of people don't consider lighting a big deal, but as a game developer, you must consider these small detail things to be really important in your video game, because that's really what drives your video game to be more of your style, right? And after we're done with the lighting concept, we're going to go a bit about levels. So today I want to make sure that we find a way to connect between our levels in the game. So you know that, like, as I go back to Unity, you can see that if I go to scenes, I have made 3 different levels, like level 1, which you see over here. Then I also made level 2, which I said it looks like a bit like Spider-Man. I don't know why. And then like the final level, right? But the thing is, we made 3 different scenes, but we never figured out how to um how to connect between them, how to like go from one scene to another. Like let's say if I let's go to level 1 actually. Let's say like over here, um let's say over here we we make this object go from here to here, and we make some sort of thing over there that if we use the on collision enter or something, then we will go to another level, we'll proceed to another level. And it's really important, right? That's a way to connect our game to another game. It's something that we see in Pac-Man, in other games, where it's like a maze game. You try to go from one place to the goal, and when you reach that goal, you probably level up and go to another maze, and you progress up and up until you probably get like a win scene or like a trophy in the game to indicate that you finished the game successfully. And this is what we're going to try doing today. We'll try making an object, so preferably like some sort of prefab, as we see over here, so we can just drag and drop it in other scenes in the game very easily. And we will just be doing that. Really, it's going to be a really fun thing. We're not really going to plan having a win scene. So like what I'm trying to say is, when we go to level 3, your question might be, yeah, sure, if we put like a prefab here of that block, that will allow us to go from one scene to another. Well, if level 3 is our final level, where is it going to take us? Well, in this sense, since this is our first game project, we'll just go back to level 1. But what you can also do is you can also just make another scene, right? You can just create a scene and maybe make that a win scene and use UI. You might want to research a bit about UI, because we haven't learned that yet, but we'll make sure to learn UI, especially in the next course, really well. But we will learn more about it when we make our final game project, which has a lot to do with UI, especially it's an FPS game. So you need to know the health counter, the kill counter, all that kind of things on your screen. And it's really important, especially in those kind of games, right? But for now, let's just take it easy. This is our first game, and we're just trying to get in touch with Unity, trying to grasp the ideas and concepts of Unity, because I know that a lot of us probably doesn't know Unity that well, and this is why you're here at the GDC, because we're going to help you in that. All right, so we're going to make sure in levels we make some sort of object that allows the player to translate, or like in other words, to move from one scene to another scene, and we're going to learn how to do that. And finally, we're going to figure out a way where we can make, like, let's say we're going to put some obstacles in the air, and we're going to make them fall at a given time. So we need to figure out how to do that. All right, so we'll figure out, like let's say if I make a cube, right? So let's just say I make a cube over here, and it's in the air. Well, what I wanted to do is I wanted to stand here where it is right now, but a few seconds later, let's say like 3 or 5 seconds later, once we pass that time, I want that thing to fall right after that moment. Well, we haven't learned about it yet, but that's some beauty about it today. We're gonna learn that phenomenon, that speculation on how to find the answer to that, and it's really gonna help you when you're gonna start making your own projects. And that thing is time.time itself. But don't worry, we'll get through that later in this course today. All right, so today let's actually start off with lighting. All right, so let's give it a moment to. Now, before I do move on, I just want to check whether you guys can hear me well. So I think you guys can, so I'm not risking it. Okay, so I never seen any chat, so that's all right. All right, so let's use the Alt tool. So let's talk about lighting. All right, lighting. There's lights all around us. There's sunlight. There is a light above us. There's probably a light next to you. There's a lamp. There's also spotlights, right? We see that in the highways, that it emits a different type of light. It may be like a cone-ish type of light. There are many styles of it. Lights appear anywhere. It's also really small. It's a photon, right? Photons are existing in the very, very small areas of life, and it still exists there. So light is pretty much important to reality itself. And it's also consequently really important to the virtual world itself, which is the place where we're going all the time, Unity. So the first question is, how do we add lighting? So if you think of it, if you want to think in terms of our wording, lighting is just a bit like a game object. You see these things over here, these things that looks like boxes, that's a game object. So is lighting. And I've already made those lighting things already for you guys as an example. But just consider each type of lighting as a game object. It's going to be pretty hard to grasp that kind of concept or knowledge, but once you understand that, hey, lighting is not it's not as different as a game object. They're pretty much the same if you think of it in this virtual world. Well, if you think of it in reality, it's not an object, right? Light is its own type of matter. It could be anything, but it's definitely not like what we are. It's not an object. But just think of it when you're in Unity or in a game engine, just think of lighting as a game object. You're just importing some sort of object that Unity has made, and you're just using it. And these things have its own components, as you'll see over here. And you can, tweak a lot of things with it and go hands-on with it. And really, it becomes your own unique game from doing such a thing. All right, so one way to add it is, well, this is the hierarchy panel, right? So you can right-click on the hierarchy panel and click on lights. So don't go to 3D object now. We're going to lights. Now we can see, well, there are many types of lights, which we'll go over today really specifically, especially on directional light and point light and spotlights. Area light, reflection probe, light probe groups, they're not as important for what we're going to learn today or in this specific project, but I will still go over it, especially for those who are really, really interested and are really true avid game designers. And you really want to learn more. But that's the point. We want to learn more in game development, and that's just boost up our knowledge and get to know more about other things in reality, right? So yeah, so today we're gonna focus on these 3 specific lightings, but this is one way to do it. You can just click light and just import a spotlight, and this is a game object it's existing over here, and you can move the location and stuff. But for now, I will just delete it because I already have all the lightings ready for me. Okay, I'm just going to save that. Another way you can do it is you can go up to the game object. Well, this is obviously a harder way. And you can go to the lights and get it over here as well. All right, so it's just basically almost like a one-click button or a few clicks. But still, it's just a button away from just clicking that thing, and you'll get your light inside of your environment. All right, so lighting is also a game object that exists in the environment. It has the similar properties as just other game objects out there. You can also make a lighting a prefab, but nobody really does that, so don't worry about it. All right, so these are like ways to add, and you can always come back to this. It's in the resources tab. It's in the keynote channel on our Discord server if you want to access it anytime. So no worries there. Now, first thing, let's talk about directional light. Directional light is a bit linear. As you can see, it's like straight line. But you need to always know that directional light is a type of light that is automatically created when you make a scene. So if I actually go back and I want to make a new scene, so it's like create scene. And I'll just create a new scene. I don't care what to name it. But you can see if I create a new scene, a new directional light is formed. So whenever you make a new scene, two big things, as I said, are made. One is a directional light and a camera. And everything else you can tweak it later with by adding 3D objects and other stuff like lights, audio, video, UI, that to add the counters and on the screen. But for now, you just need to know that when you make a new scene, you always get one light ready for you, and you can just tweak the stuff from there. But we want to understand what directional light really is. Like, what is it that stands out from other things? One is that, like, if I move the environment around, like if I move this thing around the place, it's not going to change the lighting anywhere. However, if I press E and I start rotating the lighting, that is how, lighting is affected in terms of, using directional light. Now you can see if I just put it up, it's all dark now. But if I put it more down towards the bottom of this environment, it gets brighter. And if I get to the top, it gets darker. So directional light has more to do with rotation than movement. And that's honestly all the things you need to know. It is automatically made for you. And you can have more than one directional light if you want. Preferably, usually people just put one, but honestly, it's up to you. But it only works. The lighting changes and modifies only when you rotate. And that's the big point about basically directional light. Also, you can change the color of directional light. I think you've seen that in my other levels in the game. I changed the color of the directional light. Honestly, get the color that suits your type of game. Since my game is more futuristic, I would go for neon colors. But if your game was more like in the jungle, you might go for something bright green or dark green or maybe orange, depending on where you are in terms of geography. Or if you're playing a Mars game, make it very dusty, this feeling of dust. It should be like a bright brownish color that kind of gives a sense of dust around the place, right? So just to tell you, this has a lot, and there's like a lot of cool stuff that you can do with this, but for now, this is just like an indication to just tell you that this thing exists. For now, I'm just going to delete the scene. You cannot undo this action, obviously, but don't worry. I'm just going to save it. I didn't delete it apparently, so I'll just delete it now. All right, that's good. All right, so that's all about directional light. That's all you need to know. It's straight, and it only modifies only if you rotate it. Then there's point light, okay? There's another type of light here. I will show it to you right now. It's a point light. So instead of being straight line, it's more of a spherical shape, more like a planet shape in a way. And what it does is it's a bit more different than a directional light. Because one, you can actually change the lighting even if you move. You can modify the lighting around the environment even if you move. But the thing is, it won't modify at all if you rotate it. Like, literally, it doesn't. Why? Well, because it's spherical. And what it's doing is it's creating lighting based on the range you gave. So over here, I gave my range as 44.7 something. So you can see that if I actually zoom it out, it's pretty big. You can see it. Alright, so I can actually increase the range. So if I increase the range, this is like how much the light will spread across the environment. And right now it's pretty large, if you can see. And I can change the color. Right now it shows red. But the only thing you need to know is you can move it around the environment, and it's more like, it's used to show an indication in the game. People use it as an indicator to let the player understand where to move around the game. Because usually maybe your game is really dark, maybe it's like a horror game, so they probably make these point lights to give like an indicator that the person must move at a certain place. In one of the games that I made, I usually put point lights on a goal, like where the person needs to go. So it kind of gives an indicator that, okay, this is where I need to go. It's kind of a light detector that kind of detects a person's eyes and say, oh, okay, that's where it goes. It kind of helps guide the player. It's a great user experience tool for you all to use, all right? So yeah, you just need to know that you cannot rotate it, but you can move it, and it's really helpful for guiding the user. All right, then we also have Spotlight. Spotlight is commonly used, obviously I think you might know Spotlights. So You might have a stage. Let's say you made a game where there's a stage and you wanted to add some lights on it. Now, if you see, you cannot really theoretically use a point light, because point light is making a, if you're, I'm saying if this is a stage, right, and you're making a, let's say the game was a concert kind of game or you're playing some drums, you cannot be using a point light, because point light is just, it's probably somewhere and it's just spreading out from there in a spherical manner. But point light is directing the person. Now, if I actually go to level 3, because I'm gonna give a great explanation here. I put a lot of spotlights, as you can see over here. It's kind of like a cone, if you think of it. So if I go to lighting and I click on spotlight, yeah, so you can see that over here, it's a bit like a cone shape. It's the same thing as what people use in high vis. If you see a high V light, it kind of creates that effect as well, a cone effect, as you can see over here. Similarly, if you're in a concert, people use spotlights, and spotlights make like a spot at a given stage. Point light doesn't. It doesn't give that circular shape down there. But spotlights indeed do, and people use it when they want to make like a highway, and people put this, or as I said, in a stage or something. But honestly, people go creative with it, but you should just know it's spotting at something specifically, and that's why people use spotlight. Directional light is more on the environment, if you want to make the environment dark or bright. So it's nothing to do within the environment. It's more like outside over here for directional light. And the point light is just at a specific place, and it's just spreading the light from there easily. Okay, but spotlights help, help emphasize light on a particular region of a circle in your environment, like we see over here. So that's like the three main type of lights that I want you to know a bit about, and it's really gonna help you go really crazy with it when you're making your own game. Right? So just honestly go crazy with it, play around with it, tweak with a lot of numbers and things over here, as you can see. I just randomly tweaked the numbers, and I got what I wanted, honestly, and it looks okay to me. Maybe not good to you, but it's my opinion. It's my own game. But again, critics are always acceptable. I want to make the game better. So yeah, I think that's basically it in terms of the lightings we need to know. There's like, I think, 3 more types of lightings that we need to understand. There's also something I forgot to mention. There is a light called area light. We're not really going to focus on area light at all. Usually not a lot of people even use area light. People usually use directional point light or spotlight. But people don't really use area light, so I don't really want to go over it. I will put like some videos in the resources channel if you would like to go over it as well. But we will maybe use it in other game projects for now. But right now, area light isn't as important as it is. But for now, even though also reflection probe and light probe group, even though these things are also not important for this game, we're still going to go over it because it's a really, really cool tool that makes your game looks a bit more RTX-ish with high-end graphics. So let's talk about reflection probe. Now, look at that. Oh my god. You see that? That's amazing. That's a masterpiece. Look at that. Look at that amazing reflection. You ever wonder how reflections even work in Unity? Well, basically, they use reflection probe. So how things work is there's a camera, some sort of camera in Unity that kind of captures the direction of light in every single place of that environment in 6 directions. Because if you didn't know this, reality is actually working in 6 DOF, which is degrees of freedom. You can study a bit more about it. You'll learn eventually about this in engineering class or something in science class. But it's degrees of freedom. We live in a 6 degrees of freedom environment. So we have top, bottom, right, left, back, and front. So that's like 6 different sides. And what reflection probe is doing, it's capturing light from all these different directions. Now the thing is, that's cool. That is a thing. But it's a camera, right? It's basically like a camera. You cannot put a camera on a material. The goal is that we want to make this kind of reflection happen as a material, and you can paste that material on a specific object. Well, this is where cube map comes in. Cube map is just storing that image that's captured by this reflection probe camera, and it's making like a box. Look, you can see that it's like a box. It's outlining and making a foundation of the light base, and then you can just code it over the object that you want to put it on. And then, as you can see, it's gonna like surround the object itself, and it just kind of makes an illusion that, well, there is a reflection happening on that material. And oh my god, that is very shiny. I like it. Okay. You can also refer to this on, you can look at this video because I got information from this. It's a really helpful YouTube video. It's from Unity 2017, even though it's an old software, like an old version of Unity. I think it's still applicable in the new versions as well, as far as I know. But this is the science behind it, and it's really, really cool. All right, then let's say sometimes it's not about the reflection. Maybe in your game it's about the light. And if you want to walk towards a light, you want to get that feeling that the light is shining on you, it's coming on you, right? It's not like reflection. It's not like where, this thing will reflect what's around the environment. Rather, you, the object that's going towards that object, you're going to get that light coming in. And that's where Light Pro Group comes in. This is where we make the game look a bit more, I think, better in terms of aesthetics. It's a really, really great tool. There's a YouTube video that explains it really well how to apply it and stuff. Right now, we're not going to go over it. Maybe on the final project, we can, apply this. It's really, really fun. And once you apply that on the object that has the light probe, anything that's around that will receive that light on the object itself. So it's kind of like a opposite version of the reflection probe. Rather, it's not that object that you're putting on that's getting that reflection, but it's the others that are. So it's that kind of concept there. It's pretty cool. And you can clearly see that over here in an example, like this player, this girl, is walking towards the blue object. This blue object has the light probe group material. And once the girl gets closer, it's actually getting more blue. So the girl accesses the surrounding environment that's getting the color from this thing that has a light probe group. And similarly here, it's yellow, and we can see that sphere object that they created in Unity that's getting, as a surrounding, the yellow color from this object that has the light probe group. All right, hopefully that makes a bit more sense. If you kind of find that confusing, don't worry, be sure to reach out in Unity, and I will be sure to help you out in fixing that clarification. All right. Yeah, so for now, you guys can ignore reflection probe, light probe group, and area group because we will learn more about it in the future, and it's kind of a complicated topic, and it's not really as necessary in this first game project because I don't want to fry your brains out in that final game project, all right? And speaking of the final game project, you will have to make a 15-second video or a 30-second video, maybe a 15-second video because I don't know if you could upload it on Discord due to the file size things. But what you're going to do is you're going to show a mini gameplay of how things are going, and there's some requirements that you need to show, like the movement and going from one place to another, transferring between scenes, and also showing some cool stuff as well. But what will happen is, I said, the person that has the best video, which is selected by the GDC team with some requirements, we'll also share that out soon in the Discord server, will get that award that I mentioned in the announcements. If you don't know the award, be sure to check the announcements again, and you'll get your answer over there. All right, but the importance is these three different types of lighting is not really important to learn right now, so we can ignore it for now. All right, so let's talk about levels. Levels is a really important thing, as I said. It's going to be something that's going to help us, interact with the game even more. It's going to help us move between scenes in Unity, which is obviously important. We don't want to just be stuck in one scene in this entire game that you're playing. You probably have more scenes to play in, and that's really important. So let's understand, the scenes in this scenario will be levels. We made different scenes as a level, basically, and and we just treat it like that. So don't think that scenes is just for levels. There's more ways. There are many other reasons that you could be using scenes for, but levels is one of the reasons why people use scenes to distinct different levels in the game. And we'll be using that because this is a maze game, and as you progress through each game and you finish each scene, you're going to transfer to another scene, which is kind of illusioning yourself as progressing to a new level. All right, and for us, as we move on, we're trying to make the game a bit more harder for the player so that they don't kind of get bored and lose the player experience as well. All right, so for now, what we're going to learn is the first step is that we want to add all the scenes in the build settings. So when I say that, I'm saying that we go to this, go to File, and you go to Build Settings. And you want to click on Add Open Scenes. And what it will do is it will open the current scene that we have open, which is level 3. We can also, I think, drag the scenes here as well. But what we'll do is we'll make an index. So what I want to do first, whenever you put these things in your build settings, you always want to order it from least to greatest in terms of levels. So level 1 should come first, and the last level in your game should come last. So any game that's the first level should always be on top. And it's going to progress down and down, because what I'll explain why is because there are some build index here. We'll be learning about build index right now. I'll be explaining right now what it is, and it's basically that you're referencing a specific scene in Unity with an index, and you can access that index inside of a script whenever you want to say, okay, if I go somewhere here, if I touch something else, then we could load the scene using a thing, as I said here, called scene management, which will import in our script. And from importing that, we can say, hey, scene manager dot load scene, and we could put either a string, the name of the level, which is either level space one. Again, it is very case sensitive because it's a string reference. Anytime it's a string reference, you need to always be careful with the spelling and everything. Otherwise, you might get errors in your code and nothing will happen. So yeah, you could either do string reference or put the scene build index. If you never know the build index, always go to the build settings and open it. The cool part is once you put all of the scenes here, which I think looks good to me, I can just close it and it's saved. So if I actually go back, it's still saved as it is, and that's something that I really like about Unity. All right, so the idea is, what should we do to go to the next scene? Well, for now, I just want to give like an abstract idea of what I can do. Right now, I just want to show you how to go from level 1 to level 2. Right? This is like the most basic idea. So what we'll do first is we'll create a cube. We'll create any cube we want, honestly. It's a very small cube. So I'm just going to move it first of all. Oh wow, I'm having a lot of great technical difficulties. Okay, so I'm just gonna make this a 5 by 5 by 5, or maybe the y-axis should be like 1 or something. Yeah, and I'll just put this here, right? And maybe I'll make like a new, like, I'll make this a prefab, so I can just let me just go to prefab, and I'll make this. I'll rename this first of all to, let's say, the goal, let's say, and I can just drag this. And what I can do now is I can just double click on this, and I can make a material. So let's go to the material folder, and material, and I'll just call this a goal mat or something. Yeah, and I'll just drag it to this. So whatever I change now will change that. So I'll make it like a greenish color. That looks okay to me. And oh, okay, that's actually an interesting look. All right, that is very interesting. So what we can do now is we can add like a script on this, and we'll maybe call it like a goal script. So let's just create a C# script, goal script. Or I'll just call it goal. That's also okay. Oops, I think my Unity is crashing. What just happened? Okay, and before we do anything, I think we should go back to the prefab and do the changes so that if we apply it to the other scenes, it's also changed over there as well. So let's just go to our scripts, and let me just click on the goal. And what I'm gonna do is I'm just gonna add the component goal right over here, and I'm just gonna open it. And okay, Unity's lagging today. All right, there you go. Well, apparently that worked. I'm just gonna save these things. I don't know why it was making a problem. All right, so I remember in the previous lecture, if we looked at it, we made a void on collision enter. We're gonna be using the same thing again. All right, so we can remove the start method, I believe, because we used the update method. Or wait, no, we didn't. We made our own method. So we're gonna make a void on collision enter, and we can do collision, and inside of this, what the idea is, what happens when this goal touches another cube. Well, what we want to do first is we want to import using, as I said, using Unity engine dot scene scene management. All right, so now you can see that right now it's like grayed out because we're not using it. But as I said over here, if you come back to this thing, we can do scene manager dot load scene and then just type the scene. So scene manager dot load scene, and within the parentheses you can just type the index that you want to move on. So I believe index 1, the number 1, is going to be level 2 in the game. All right, so if I go back to Unity, all right, let's just first of all, let's make sure that this object is right below the ground, so that what happens is if we, yeah, so you can see that the thing is a bit, you know, there you go. I think that's all right. So if we play the game now, I believe that if the player starts hitting that object, we should move on, right? So let's just give it a moment. So if we go forward and we touch that object right there, we should proceed to the next scene, which is kind of interesting. Well, in this scene, though, I didn't add the third-person camera thing. I should be adding it soon. My apologies. But that's the idea, that once we use this object to proceed to other scenes, it's going to help you throughout the game. Now, there's going to be one bug when you're gonna start adding the gold thing to each levels in your game. It's that this is not going to help you, because if you're going to go to level 2, right, which is basically this, and you're going to finish level 2, well, you're going to load level 2 again. So regardless of any level you're in, you're just going to load level 2. But no, the idea is we want to load the next scene in the game. So I'll leave that to you now. That's going to be one of your assignments. You're going to have to figure out how to do that. And I'll figure out I'll send the answer in the submissions channel on Friday, so you guys can check it out. But I just want to give you some brain cool activities. You guys can search it up on Google as well. You can use the grepper extension. It's again found on the GDC resources channel. But that's going to be one of your challenges that you should be doing before next week's, okay? So this is what I did. We basically made a really cool way to transition between scenes using some goal in your game, and once an object touches that goal, you can proceed to the next scene. But your job, as your homework later on today, is to figure out how to change the scene consecutively, depending on what scene you are, and that doesn't depend on anything. Like, regardless of what scene you're in, it's just going to load the next scene. So you might have to use some hints like build. You might want to use this build index plus 1. I'm just going to give you that as a hint. It's something about this build index plus 1, and you can search it up later at your own time on Google. Okay? Yeah, so you want to know that each scene has its own build index, and we use that index to reference that specific scene in the code. So this is a way to communicate between you and the scene itself. So like how to tell the computer, how to tell Unity that, hey, I actually want to go to this other scene. So Unity engine.scene management really helps you there, because it allows you to use this method, load scene, that's from scene manager, that allows you to, load a specific scene with this given index, which you've added in the build settings. Right? And you can always find the build settings. And if you don't know the build index, you can always string reference it. Like if you, instead of putting 1, you can put the string. So if you want to load, like, let's say level 2, you need to make sure it's level 2. But at the same time, you need to also know whether it's the same as well, right? So you have to go back to the scenes. And yep, that seems about right. But just make sure it's case sensitive. So it has to be spelled accordingly as it is, or otherwise it's not going to run at all. But for now, I'll just leave it at build index, because usually case sensitive. A string reference is always case sensitive, so to avoid that problem, just leave it with build index. All right, so my personal advice is always go for build index over string references. Okay? All right, so we're going to top it off this entire lecture with time.time. So what we want to do hypothetically is, if I go back to Unity, is that if I create a 3D object, let's say cube, and I'm probably going to want to, change the size of the object, maybe. Maybe let's not do 5, let's do 3, because that 5 seems like a really big amount. And I'm just going to increase the height of this, probably somewhere here. Right? Now you can see that if I actually just put it here, right, if I just play this right now, I don't think it has physics. That means it doesn't have gravity. Okay, so if I actually go play the game right now, you can see that it's just there. It's not falling down. But our idea is we want this thing, like let's say like right now, the only way to fix that is just add rigid body, right? So let's just add rigid body. But our idea is we want to figure out, a way to say that, okay, at this given time, even if it has rigid body, which it should for it to fall, maybe like after 3 seconds, I want it to fall right after that. So before that, I don't want it to fall or anything. Okay, so what we need to do is make like a new script, which I already have made for you guys, and I want you guys to make a new script called dropper. All right, so in this dropper variable, this is a goal, so we need to actually go back here. We make a class. So first of all, we want to initialize some sort of variable that will store the time delay. Okay, so what I kind of recommend now is I think I should make this a prefab so that you could access it later. So I'm just gonna call this air obstacle, maybe. I don't know, air obstacle. Just to say that it's even though it's an obstacle, it's like found in the air. Okay. So I'll just make it a prefab, as you can see here, so I can access it as many times as I want in my own scene. Inside of this, though, I'm gonna add a component which is the dropper. The dropper script, as we can see here. Okay. And what we want to do first is we want to make a serialized field. So what serialized field does is we can change the variable, as I said in the previous lecture, manually inside of the game, which is kind of insane if you kind of think of it. So right now we haven't made it, so let's make the variable itself. So nope, that's the wrong brackets. Let's do serialized field and space, and we want to maybe not private. Let's let's do private, because private is like you can only access this variable in this script, and we'll probably never use this thing at all. So we're gonna call it private float. You know what? Let's actually not bring that up. Let's call this an int, and we're gonna call this time delay, and we're gonna set this equal to some sort of value initially. So we can just initialize it to 0. Okay, so if I save it now, and I open Unity back again, why is Unity bullying me? Yeah, you can see that the time delay has changed. So you can manipulate with the variable. So you can't see it right now, but you can see that the time delay over here has changed. Okay, so now what we want to do is, given the time delay, what I mean by time delay really, is that this is the amount that I want at that instant to make that object fall. So obviously we don't want the time delay to be 0. So actually I'm just gonna change 0 to 3, like as the default amount. And what I want you guys to do, what we want to do now, is in the update method, we want to make a condition. Okay, and this is where we use time.time. But before we talk about time.time, let's actually understand how time.time works. So let's actually use debug.log, and we're gonna just end it with semicolon to get mad at us. And we can type in time.time, and once we put that inside of debug.log, and I save it, and I go to the console, right? After I play the game, first of all. After I play the game, so you can see that this timer that I made here, it's changing the time every single second. Okay, so that's what timer is. It's saying how much time has elapsed, how much time has elapsed since you start playing the game, which is kind of cool, and it's gonna be a really helpful tool right now to figure out like if the time is greater than the time delay variable we have. That's when we want to make our condition true. That thing where we say that, hey, now that's the time when things should be falling. So we want to say, first of all, if time.time is greater than or equal to the time delay, inside of this code, this is where we type the action. But we really don't have anything yet. We don't know what to type. So first of all, we need to get an object that will get the component inside of this thing. So what are things that we want? Well, we want the component of rigid body so that we can, toggle on and off for the rigid body, whether it should be on or not. And then we also, whether we want to use the gravity or not, so we can toggle this or off. And then we can also use the mesh render over here. Mesh render, remember, if we turn it off, it's just going to turn off the mesh render as well. Right? So we want to also not make it shown in the game because it could ruin the player experience, because you can see over here, maybe just a bit briefly, that it creates shadows. Now, hypothetically, imagine that you have like millions of these things right around you, right? It's all around your game. It's going to create annoying shadows, and we don't want that. So we can use the mesh render as well to remove that kind of stuff, just to not have it shown in the entire game at that given, time limit. So I'm just going to clear this just for some space. So I'm going to go back to Unity, and what we want to do first is we want to, in the start method, we want to reference some stuff. So first of all, we'll make an object called renderer, and I don't want it to be capital. I'm just going to make it lowercase. Always make sure that objects and variables, they're always lowercase compared to the actual component itself. So then we want to get component. And actually, although this thing I have is kind of automatically doing it for me, remember, get every method ends with the parentheses, I said in the previous lecture. But inside of this get component, we want to access what do we want to access in the renderer? Well, we want to access the mesh renderer, right? So I'm just gonna, there you go. Wait, I don't understand. This doesn't make sense, bro. Okay, I feel like something just happened. Wait, that doesn't make sense. I don't understand. Hold on. I guess, wait, hold on. Let me just, well, let's just ignore that, because usually that shouldn't be a problem. So then what I want to make is a rigid body kind of component. So then I would get the component, and what I would type is obviously the rigid body, and just end it off. Right now, I don't understand why. Or maybe, wait, hold on. I might need to initialize it here, first of all. So rigid body. And then I would want to... Yeah, okay. So you need to make sure that you do initialize it over here as well, because in the new Unity versions, they don't allow that, sadly. Nope, that's not what I meant. Renderer. Okay. So now we can see that we need to initialize on top, like make an object, and you make a primitive type, which is rigid body. So apparently, it's very sus. Oh, okay, it's because it's capital B, but it's still making a problem. No, it's not. Okay, that's good. So then, you want to first initialize making an object, what type it is. So you can always find the type of it over here. So mesh render is like this, and rigid body is here. You should just type exactly as it is, and then you make an object name. You can call it whatever you want, but I made a rigid body and render. I made it lowercase, and in the start method, I access these components by giving a reference to it. What does this, what does it store? So the renderer stores mesh render, and rigid body stores rigid body. So then what we can do now is we can make renderer. We can access these things in the beginning, and dot, and then we could say renderer dot maybe enabled, right? And maybe we want to make it false. And what this does is you're accessing the enabled button, and over here, this button here, enabled. And if you toggle it off, well, that means you cannot see that in the environment. But we also want to make sure that gravity is also turned off, right? So rigid body dot use gravity is also false. Okay? But then what happens is here, we want to make it the opposite. So if it's after 3 seconds or after the time delay, I don't know why that did not copy everything. Yeah, so let me just, man, Visual Studio sometimes, bro. Alright, so basically what happens if it's greater than the time delay, we want to make these things become true. Okay, so let me just... There you go. You want to make it true, okay? And we can save this. Hopefully, I think it should run. Please don't kill me, Unity. I've been using Logic all day long. Okay, so don't worry about, I guess, those stuff. I think it should work. So let's play the game. Let's give it a try. So at the first 3 seconds of the game, you shouldn't be able to see it. Oh, apparently you see it. Okay. Let me understand why. This is very sus. This has never happened to me. Oh, okay. It's because we made the time delay 0. So we need to make sure that the time delay is not 0. Okay, and we save it. So my apologies, I did not see that right now. Let's actually just play it again. Yeah, so first of all, you can see that, oh, it's not here anymore. But after 3 seconds, we can see that, oh, it's back there now. Okay, so this is what we need to know. We need to understand how these things work. We need to understand like how collisions work in the game. And really, that's what we did. Like at a given amount of time that you decide to put over here, that is what determines that after what given time you want it to be enabled, which is kind of good, right? I think this is a pretty cool tool and it's a really versatile tool that you'll be able to use in your game. Okay, so what we'll do in the next lecture now, in the final lecture, is that we'll be able to find a way where if these type of droppers, these prefabs, that's called air obstacles, if it ever touches, and including these obstacles as well over here, so not just like air obstacles, but these things as well, whenever it touches this thing, then we want to make sure that the user plays the scene again, right? We want to play the current scene again. So we're gonna learn that a bit later with tags, which is a concept that we'll learn in the next lecture, and we'll also like talk more about like how to make some more cool obstacles that can automatically rotate itself, become like a spinner per se, and we might top it off maybe with some sort of like let's say some post processing and stuff if we have time. But usually that's really it for today's meeting. Today we talked about how air obstacles work and stuff. But before we leave, let's actually like understand a bit more about time.time. It is basically just like a thing that shows time elapsed, right? And it's like a stopwatch. Just think of it like a stopwatch. Time.time is basically like a stopwatch. So we can see that in our script that time.time basically behaved like a stopwatch. So in other words, if the stopwatch, the current time of the game itself that you elapsed, the current time elapsed, is greater than the time delay, which we chose in this scenario to be 3 seconds. So if the stopwatch indicates a value that's above 3 seconds, then you want to do the following commands over here. Basically, what we just did is we just made the mesh render come true. So you can now see the mesh render of the thing that's outside of the object. It makes the object look like an object in the game. And we enabled use gravity. So, sorry Newton, we were able to mess with gravity, and hopefully you don't get upset with your Newton's laws getting affected in the virtual world. So, apologies to him. But this is like a really fascinating thing that we can do. In the start method, we just initialize it to false, but until it's some given condition in the update method, which keeps on updating every single frame. Remember about the time.delta time we were talking about? You can see that in the previous videos, but it's pretty cool. And really, that's really it for today. We just found a way to do this. What I want you guys to do, though, is, make many different air obstacles in your game and, tweak with the timer. So for some of them, make it 5 seconds, make it 10 seconds, make it your own way, make it more unique to you. And just make it cool, honestly, right? And if you ever get confused, just watch this video again on YouTube. You can check it out. And always be sure, I don't know if a lot of people are using this cool technique, but what you guys can do is if you go to the YouTube uploads, right? So let me just go over here. I have updated the timestamps for you also. Please use it wisely. Please do it. So if you play a video, right, I have made the timestamps for you all. So you can actually just skip the first 13 minutes of the video or like the first 17-ish minutes and just move on to the topic you want to talk about, right? So if you're confused about get component today, you can always go to this part of the video and you will know a lot about the get components. This is just a time saver for you all because I know that it's a 15-minute video, almost even like an hour. So I don't want you guys to be wasting all of your time. You guys have a lot of homework as well. And yeah, I really care about you all, okay? You're all students and I don't want you to make the same mistakes I did in the past. Right, so yeah, I think that's really it in terms of what we learned today. So let me just go back to the intermission. So what I want you guys to end up doing today is I'll be sharing some assignments. You could do some challenges that I talked about in this video today. Be sure to watch the video. It will come out tonight evening. I'll be doing some editing and fix the audio stuff as well. I am kind of concerned though because apparently my recording is apparently not outputting this mic, which is kind of odd. But I'll try to figure out the problem to that. If I am not able to record it, I'm really sorry. But I'll try to find a way to add it in the keynote because it's always available in this resources in the keynote channel on Discord. So in case the video doesn't get posted, just be sure to look out the keynote if you're confused. And if you're still stuck, again, use the Unity channel. You're gonna get your XPs and stuff, and it's gonna be great for you. So yeah, so that's basically it for today. Really glad that a lot of you guys have joined, and hopefully I'll see you guys in the next week. So enjoy your last few days of the October break. Peace, guys.